Okay, guys, we're looking at inverse matrices. So what we've done is we've done adding and subtracting matrices. We've done multiplying matrices. So the last thing for us to do is a special way of division. We call it inverse. So in order to divide, you go through a process of calculating the inverse, and there's a multiplication that's involved in terms of dividing. So it's like a reciprocal thing. So anyways, inverse functions only exist with square matrices. So with square matrices, remember how we look back at all those names. The common one that we're going to be working with is a 2 by 2, whereas any square matrix like 3 by 3, 4 by 4, 5 by 5, it will contain an inverse. So there's a mathematical process. So for your matrix, like we said, we're going to commonly work with a 2 by 2. So let's say the A matrix has some number A, some number B, some number C, some number D. What we need to do is we need to look at two different things. So first of all, we need to look at this new terminology called determinant. So determinant is just a number. Notation for it is det, just to shorten the determinant down to just the det of A is equal to the numbers inside multiplied in a particular order and subtracting each other. So it's the diagonals. A times D, take away B times C. So that's the order. So this is a formula that you guys are going to use. Once again, I'll show you guys the CAS way of doing it. And then when you have this particular number, it doesn't matter if it's positive or negative, as long as it's not zero. And we'll talk about that in a second. So with the inverse, A represents your normal. A inverse, just think of it, power of -1. You guys would have seen it before when you did things like trig, sine inverse, cos inverse, tan inverse, power of -1. So the way that it works is 1 divided by that number that you just worked out. So this could be 10, -6, whatever. And then inside, this is where it gets confusing. Inside, you swap these two, and then you times these two by negative. Now, if you guys are thinking, wow, that's super confusing, it's okay, only because there is a way to do this on CAS. Super easy. And once again, for every assessment that you guys do, you will have CAS with you. So to double check if it is an inverse, you got A times A inverse must be I. So what does I look like? So I is what we call identity matrix, which represents ones going diagonally. So if you have this particular order, this is the identity matrix for a 2 by 2, because that's what we're going to commonly work with. That means it's an inverse. So A times its own inverse must be ones in the diagonal identity. So going back to that point, when you work this out, it has to be a number, because when you do 1 divided by a number, it works. The only time that it doesn't work is if it's 0. So if you do the maths behind this and it's 0, it just means 1 divided by 0 mathematically does not work. So we call that a singular matrix. So a matrix that does not have an inverse is called a singular matrix, and it only occurs when the determinant is equal to 0. So here's another name, singular matrix, meaning inverse does not work. You can't divide. And the only way that it works is if determinant equals to 0. Okay, so let's say we do this partially by hand. Determinant of A. So determinant is A, D minus B, C. So this in its particular order is A, B, C, D. So this becomes, I'll do it over here, 5 times -2 take away 4 times 8. So 5 times -2 is -10. -4 times 8, which is now -32. So then this works out to be -42. Okay, so that's my determinant. So notation is det determinant of the matrix A. And you'll see that when we do matrix B, it'll be determinant, and instead of A, we'll be using B to justify or to show that it's matrix B. Okay, so then from here, the inverse is that formula that we just looked at, so the ugly one, and it's confusing. And like I said, if you want to do this on CAS, I would highly recommend it. So then it's D minus B minus C A. So that's my inverse, and notation is power of -1. So the way that it works is 1 over -42. And then my D is -2. My B, I got to times it by -1, so now it becomes -4. And my C becomes -8. And then my A sits up, oh, was up top, now it's at the bottom. So that's what my new matrix looks like. And then with this, you're just going to multiply it in. So you're going to times everything by -1/42, or 1/-42. So you're going to multiply all that in, which I'm not going to do because then it gets messy with fractions. And then I'll show you on the CAS, and then I'll talk to you guys about, yeah, they just simplified the fractions, not the end of the world. So let's try to memorize this. So when you go menu down to matrices, what you'll notice is this guy, determinant. So determinant. So obviously we can't just write determinant of matrix A because it doesn't know what matrix A is. So we're going to tell it what matrix we're working with. So first of all, must be a square matrix, so 2 by 2. I'm not gonna lie, I've got the numbers. So 5, 4, 8, -2. So 5, 4, 8, -2, and just like that, there's my determinant. So instead of going through the formula and calculating it, CAS will do all the work for you. Now, if you didn't work out the determinant by hand, you wouldn't be able to work out the inverse by hand. So what needs to happen is we're going through the process of doing this on CAS where you don't even need to have the determinant. So say even if we didn't do this step, CAS can still work out the inverse for you. So the way it works is, oh, not finance, we're done with that one. 2 by 2, 5, 4, 8, -2. And the way it works is power of -1. So that -1, here it is. So what it's done is, do you know that -1/42 at the front, it's multiplied everything inside, and this is what it looks like. Cool, and just like that, we're done. So here it is. Let me get rid of all my, that's it. And then you guys can have a go at doing it with B. I'm just gonna give you the answers. So once again, determinant, you just gotta put it into CAS. Matrices, inverse of B, same thing, but this time can you see that it's determinant of matrix B? So if this was C, we call it C. If this was D, then we call it D. So just be consistent. There it is. So determinant of my matrix B is 21. Inverse, all I have to do is just put it to the power of -1, and CAS will do all the work for me. So show that they're inverses of each other. So remember at the start of this that if you had A times A inverse, only with its inverse, it must equal to I. So that's why I've left this here. So if we're calling this A and we're saying that this is the inverse, that means if I was to multiply them, that should give me the identity. So that means if I times the 2, it should give me my identity. So there it is. So 3, 1, 5, 2 multiplied by 2 minus 5 minus 1, 3 multiplied out gives me this. And if you're looking at this, we can then justify the answer saying that, yep, A times A inverse is identity. So therefore this, oh, they're inverses of each other. Okay, so if you wanted to do this by hand, once again, I don't recommend it. Determinant of this matrix, we have an unknown, so we don't know what this one is. All we know is the value works out to be 14. So we're doing it by hand. Let's call it matrix A. A, D minus B, C. So you got 4 times 1 take away B, which is now -5 times C, which is X. So this works out to be 4 plus 5x because 2 negatives multiplied to give you a positive. But let's say if you don't want to do this by hand, there's nothing stopping you from just doing determinant of this. The exclamation mark just pops up because it says, hey, we didn't get a proper value. We don't know if X is a number, if X is a variable. So they're just like, look, we're just going to leave it like this, which is what we got. So 5x plus 4 is the same thing as 4 plus 5x, same. So now, can I let that, so we know that that should be equal to 14. So if I let it equal to 14, we're not expecting you to have algebraic skills because we're skipping the whole chapter. So we're just asking you to use the command of solve, comma, x, like this. So solve it equaling to 14. We're solving for the letter x equals to 2. Now, if you guys are confused about that, I'll just show you guys quickly. If you can go menu, algebra, solve, or you can just type it in. So you guys type SOLVE bracket 5 times x plus 4. Oh, the issue here is because I've used x somewhere else and I've saved it, it would have been in one of the previous exercises. Because I've saved x, it's going to remember x as one of the matrices instead of a variable. So technically, if you guys see it pop up as something weird, you can technically change it to another letter. Let's say I didn't use m yet, equals 14, comma m. So we're just changing the letter. Now, if you don't want to do that, you press Control Pages. I don't know if you guys can see it, but I saved all the matrices there. So I'm going to delete everything, and it says deleted all the data. Are you sure? Yep, delete all the data. And if we go back, now we can use x freely because it doesn't remember what x is anymore. So what was it? Something like this, comma x. Yep, there it is. Cool. So just in case it pops up, and it does because we do save x as the list of spreadsheet, we do save x as matrices, and it remembers that. And to get rid of the data, you just delete the page. Okay, so explain why this doesn't have an inverse. Well, if we go through and we work out the determinant equals 0. So that last line on the first page stated that in order for you not to have an inverse, it's what we call a singular matrix. So in order for you to have a singular matrix, the determinant must be 0. So that's all it is. So once you put it into the CAS, you just write, yep, the determinant is 0. Therefore, this matrix A does not have an inverse. And the name for it is singular matrix. All right, that takes us to the end of 8.4. Done, guys.